Welcome to homework.
For this two-part question, the first part is asking us to calculate the vapor pressure of water above a solution prepared when we dissolve 28.5 grams of C3H8O3 in 125 grams of water at a temperature of 343 Kelvin. Now, to get the vapor pressure of water, we need to put this into Celsius. So we're going to take this 343 minus 273, which will give us 70 degrees Celsius. And the pressure at 70 degrees Celsius for water is going to be 233.7 torr. Okay, so first we need to figure out how many moles of glycerin are in the water. So we need to find our molar mass for glycerin. So our molar mass for C3H8O3 is going to be 3 times 12.01 plus 8 times 1.008 plus 3 times 16. And we get that equals 92.09 grams per mole. And then let's go ahead and also just go calculate the molar mass of water while we're at it. Molar mass of H2O is going to be 2 times 1.008 plus 16, so we have 18.016 grams per mole. Okay. So to find our number of moles of glycerin, we know that we added 28.5 grams, so H8O3 is going to be equal to 28.5 divided by our molar mass, which is 92.09, which is going to 0.309 moles of C3H8O3. And then we want to find our number of moles of H2O, which is going to equal our 125 grams divided by 18.016. And we get that comes out to 6.938 moles of water. So next we want to go ahead and find our mole fraction of water here. So we're going to take our mole fraction of H2O is going to be equal to our number of moles H2O, so 6.938, divided by the moles, total number of moles in the solution, which is 6.938 plus 0.309. And we get that our mole fraction is 0.957. So we can now figure out if this is our mole fraction and this was our torr of the pure substance, we can do 0.957 times the 233.7, and we get that equals 223.65 torr. So that is going to be our vapor pressure. For part B of this question, we're trying to calculate the mass of ethylene glycol. We would need to add to 1 kilogram of ethanol to reduce the vapor pressure by 10 torr at 35 degrees Celsius. And we're told that the vapor pressure of pure ethanol at 35 is 100 torr. So first step, we want to figure out the mole fraction of our ethanol. So to find our mole fraction of C2H5OH, we're going to take the 90 torr divided by 100 torr of pure, which gives us 0.9 as our fraction. And now we need to go ahead and figure out how many moles we have in this sample. So we need to get our molar mass of ethanol. So our molar mass of ethanol of C2H5OH is going to be 2 times 12.01 plus 6 times 1.008 plus 16, which will give us an answer of 46.07 grams per mole. And then the number of moles of ethanol, we have a sample that's 1,000 grams. So we're going to figure out the number of moles by dividing how much we have by the molar mass. So our moles of C2H5OH is going to be 1,000 divided by 46.07, which will equal 21.71 mole of C2H5OH of ethanol. Now, in order to calculate the number of moles of ethylene glycol, we are going to use our equation for our molar ratio of C2H5OH equals the moles of C2H5OH divided by the moles of the whole solution. So the moles of C2H5OH plus the number of moles of C2H6O2. And we can rearrange that to solve for moles of C2H6O2 is going to equal moles of ethanol divided by the mole fraction of ethanol minus the number of moles of ethanol, C2H5. So we can go ahead and substitute in our values here now because we know we have 27.71 moles. So 21.71 moles divided by 0.9, which was our ratio, or our fraction there, minus 21.71. And we get that our moles of ethylene glycol is going to be 2.41 moles of C2H6O2. So we're one step closer to figuring out what it is going to be. Now we need to figure out our molar mass of C2H6O2. So that's 2 times 12.01 plus 6 times 1.008 plus 2 times 16. And we get that that comes out to be 62.07 grams per mole. Oops. Now we know we have 2.41 moles. So if we do 2.41 times 62.07, we get that we would need 149.69 grams of ethylene glycol in order to reduce our pressure by 10 torr.